Okay, last video for Unit 1, we're going to be looking at inequalities again, but we're going to be looking at compound inequalities and also graphing linear inequalities when there's two variables. First one we're going to look at and inequalities. And inequalities are true if and only if both inequalities are true. Okay, so both, what you're looking for is kind of what is shared in the middle. Okay, here's an example of one. We want to graph what is all the points greater than or equal to -1, and also all the numbers that are less than 2. So what you want to do on those graphs, go to the graph, make sure you can label so that all these points can actually get on there. And then you start out with the first one. So greater than or equal to -1, that's starting at -1. And going greater than, so to the right, we want to shade that in, okay, because it counts the point. We got equals here. And then the next one is less than 2, that would be open circle. Points less than are going to the left, okay, so now it's everything in between here. We want to shade that in, so it's everything in between both -1 and 2. Okay, the other type are OR inequalities. OR inequalities are true if one or more of the inequalities is true. Okay, OR means union, so both sets of points. Okay, here's an example that x is less than or equal to 1 or greater than 4. Okay, so again, make sure on your graph that you label and can get those points on there. Okay, start with the first one, less than or equal to 1. So filled in circle because it could be equal to. Less than are the points to the left. Okay, the other one is 4, open circle. Greater than points are to the right, so those ones are getting shaded that way. So this can be true for any points out this way or any points out this way. It's just the points in between that would not make this true. So solving these ones, what you want to do, look to get the middle here in between these two inequalities to be just x instead of having 2x plus 7 or whatever's in there. So do like you would normally do solving. Here we would start by subtracting 7. Now usually when there's just one equation or inequality sign, we just have to do it once. But here, since we got a second inequality sign, okay, you also have to subtract 7 from that side, okay? So now the 7 in the middle's gone. We would just have 2x remaining in the middle. Signs don't change when you add or subtract, and now subtract 7 from both. So it'd be 10, 13 minus 7 is 6. Okay, but our middle still isn't x. We want to be able to tell what two numbers this is going to be between. So now to undo multiplying, divide, but again, on both sides of the inequality signs, you got to do the same division. And so finally, our middle now is just x. Our inequalities don't change directions when it's divided by a positive. If it was a negative, we'd have to switch them. And now do the division, and we get our answer. So answer on this one would be that all the numbers between 5 and 3, including those endpoints. When graphing then, make sure you get those points on there. Okay, it's less than or equal to 5, so we want a closed in one. Less than is going that way. At 3, we'd have another filled in circle. Now here you got to be careful. We don't want to just do the arrow the same direction here like this. That doesn't work on this problem, because if we just look at this part of the inequality, you got an x, you got a 3. Notice it's pointing at the 3. So if I just reverse that, where the way we normally see it, you can see that this is greater than or equal to 3. This arrow should be going this way. So this one ends up being all the points in between 3 and 5. Okay, so be careful on these ones when they're written like that. Sorry about that. I think I misread this here. This side was not equal, so this should be open circle at this one. Okay, the one next to it, number 2. Why don't you pause the video and try that one out? All right, let's see what you got. First step, uh, looks like you should have added 4 to everything, so that'd be 15, and the other one is 12. Now divide everything by 3. We're dividing by a positive, so we don't want to switch the sign, so dividing by 3 makes us 5 and 4. On the line then, when graphing that one, um, wherever 5 and 4 are here, it's less than 5. That's going to the right. The other one's saying 4 is less than all the other numbers, which means all the other numbers are greater than 4. It's everything in between those two with 2 open circles. So that's what the graph looks like there. Some of these OR ones now, when we're doing those ones, you almost think of it as 2 separate problems here. We want to solve both sides. So first one we're going to solve here, what would this solve out to be? So do like you normally do, minus subtract 3 here, giving us negative 10x less than or equal to negative 40. Now divide by negative 10. Now here we're dividing by a negative. This is an instance where you want to make sure you've switched the direction of the inequality sign. Solving the other one, looks like we want a plus 10. It's going to give us 3x is less than or equal to negative 15. Divide by, here we're dividing by a positive 3. Okay, so no need to switch it on this one. X is less than negative 5. Okay, so now when you're graphing this one, okay, make sure again those numbers get on here. Okay, so we got less than or equal to negative 5. That'd be filled in circle going to the left. The other one is filled in circle at 4, greater than, that's going to the right. So any points less than negative 5 or greater than 4 work out here. All right, again, why don't you pause and try out one on your own, try out number 4. Okay, let's see what you got. Again, you're thinking as 2 separate ones here. On that number 4, kind of up to you what you want to do first. I'm going to subtract 6 and then add 5. Make sure when you add 5 to a negative 1, it's going to be positive 4. Divide, and you get that x has to be greater than 2. On the other side, I'm going to choose to subtract 3x first. That would leave 1x. Now minus 4, and you get negative 7 when you subtract 4 from negative 3. Not negative 1, negative 7. Okay, now graphing that, kind of similar deal here. Make sure you label it so people know which numbers are on here. And then less than negative 7 should be filled in, going left. Greater than 2, open circle going right. So the graph looks like that. All right, graphing linear inequalities in 2 variables. So if you are graphing in our slope-intercept form of y equals mx plus b, and now instead of equal sign, you throw one of these inequalities, we are again going to have a line. The line that you graph now, though, is just going to be kind of showing the side that is not solutions and the side that is solutions, because there's multiple and many solutions to these ones. It's not just a line anymore. When it's equals, it's only the points on the line. Here, it's one side of the line. So our boundary line needs to show whether we want to include the points on the line or not. If it's less than or greater than, then we use a dotted or dashed line. If it's equals to, then we use a solid line like we normally do to show the points on the line are answers. Also, then we got to figure out which side of the line to graph on. Now, the kind of the quick method of doing this is to kind of look at the arrows. If it's up, or if it's greater than or equal to, generally we shade up. If it's less than or equal to, generally we shade down. But more specifically, what you want to do when doing this is to test a point. Okay, and the point we we want to test a point not on the boundary line. Okay. All right, so let's look at some of these ones here. Number 5, we want to graph out and see what this looks like. So first thing we want to do, let's get this in slope-intercept form. We can do that by moving some stuff around here. Let's get this y by itself. So let's subtract 2x from both sides. Okay, so now we got 3y left here. When subtracting, we don't need to change our inequality sign. And since these are not like terms, we'll just write it as negative 2x plus 6. Okay, now we want that 3 gone. So divide, and you got to make sure you divide everything by that number. So now we got y is less than or equal to. Since 3 doesn't divide into negative 2, we'll leave it as a fraction for graphing here. 6 divided by 3 is 2. So now you go down to your graph. Graph like you normally do, getting points here. So start at 2. Our slope is down 2, right 3. And we just continue that to get some more points, or we can go up 2, left 3, and get some more points. Now you got to stop and catch yourself here. Before connecting these, you got to check what kind of inequality symbol. Is it solid line because we want to include it, or dash because we don't want to include these points? Here, since it's equal to, we do want to include these points. So we want to go solid line through all these points. And now that's just some of the points. The points on that line are solutions, but also one of these two sides is also a solution. We want to figure out which one it is. So to do that, we can look at the sign. It's less than. Normally, less than is going to indicate below the line. Okay, so we think it's going to be down there. Let's check, though, with a point and test. And the easiest point to test is if your boundary line doesn't go through is 0, 0. Because 0 is an easy number to work with, especially when multiplying. So if we were to plug in 0 for both x and y here, let's see what we get. So 0 on this side, 0 for x. And here's why 0 is awesome, because 0 times even a fraction here is just 0. So you're going to get 0 plus 2. And then we know 0 plus 2 is 2, so you get 0 is less than or equal to 2. Is that statement true or false? Well, 0 is less than 2. That's a true statement. That means our 0, 0 point is true. We always shade on the side that makes the inequality true, because that's showing the points. So we were correct. Everything under this line should get shaded in. You always shade the true side, not the false side. Every point you would try on this side would make the inequality false. We don't want to graph on the false side. Okay, the second one, sorry, not the second one, but number 6. Let's take a look here. You got another one. We want to get it in slope-intercept form. Here, since the x is negative, we should add it to the other side to make it 0. So now you got 2y is greater than x plus 4. Divide by 2. Okay, that's going to eliminate this 2. So now we got y is greater than. 4 divided by 2 is going to be 2 over here. This is kind of tricky with x divided by 2. What you got to think of is, what is that number in front of x? Anytime they don't show it, it's a 1. So our slope here is 1/2 x. So now on our graph, let's get the line again. Start at 2. Our slope is up 1, right 2. So we'll get those points on there. Okay, or we could go down 1, left 2, and get these points. Okay, now we want to think, should we go solid or dashed or dotted here? Looks like without the equal sign, we want to do a dashed or dotted line through these. That's showing whoever's looking at our graph, all those points on the line are not solutions. They don't work. Okay. All right, last we want to shade now. Generally greater than is going to tell us to shade up here. Let's just make sure we got it right here. Let's test 0, 0 again. So if we test out the point 0, 0, since our line's not going through there, we get 0 is greater than. Half of 0 is still 0, plus 2 would be 2. Is 0 greater than 2? No, 0 is not bigger than true. That means this side comes out to be false, because here's where 0, 0 is right here. That means the set points on the other side of the line should come out to be true. we always shade the true side. So we were right on our guess here that it should be above the line with greater than. So any point I'm shading in here, all these points, if you plug it in that inequality, make it come out to be true. We don't want to shade on the false side. All those points are not solutions. Okay, this next one here, why don't you pause the video and try out 7 on your own and see what you come up with. All right, let's see. You're starting at -2. Slope is up 2 over 3. We can easily get some more points here. Now, once you got your points, decide, and on this one, since we have it doesn't have the equals to, it should be a dashed or dotted line, so make sure you didn't do solid line on this one. It's tempting because we're so used to it, but you want dashed or dotted. And then this one is less than. Normally less than is going to be below the line, and if you did shade below the line, you were right, because if you test a point such as, again, 0, 0 would work. You get 0 is less than -2. 0 is not less than a negative. 0 is bigger than all the negatives. That's false. That means where 0, 0 is this point is false. That makes all the true points over here. And we always shade on the side that is true, not the side that is false. All right, one more of these here just to make sure. This one, when getting it in slope intercept form, we'd want to get that x to the other side again by subtracting an x. That cancels that out. Now, writing out the rest of this, we're not quite to slope intercept form because we got -y is less than -x minus 2. To get rid of that negative sign, we want to divide by -1. And dividing by -1 here will make this now positive y. It'll also make it a positive x and a +2. But remember, also when dividing by negatives, you still switch the sign like you would on anything else. So now we want to graph that out and see what we get and shade in like those other problems. So graphing this, you get 2, slope is 1. Remember, it's 1 if we don't see anything. Here, it would be solid line connecting these. And then greater than, usually again, is telling us to shade up here, and it would work out because if we put 0 in here, we get 0 is greater than 2. 0 is not greater than 2. There's our 0.00, which is false. And so we want to shade on the true side. All right, last thing here, if you get some word problems that have some inequalities involved, we want to be able to solve those. So Manny has $15 to spend at the fair. It costs $5 for admission, 75 cents for each ride ticket, and 25 for each game ticket, right? An inequality for the number of ride and game tickets he can buy. Well, right off the bat, we know if he has $15 to spend, we can't be spending any more than that. All the other stuff needs to be less than or equal to the $15. What it costs to go in is $5. That's a one-time cost, so we don't need any variables there. Plus, if he wants to go on any rides, that's going to be 75 cents per ride. Plus, game tickets are 25 cents, so 25 for each game. And all that stuff needs to be less than 15. Since 5 here is a constant that we can move, let's just go ahead and minus that from the 15. So it looks like really when we're doing these problems here now, our inequality is going to be that the rides and the games together have to be less than or equal to $10. So for part A, it says if he buys 10 game tickets, how many ride tickets can he buy? Well, 10 game tickets, that means we want to put that in for G here, and we can find that out. So 75 cents for each ride plus 25 cents for the 10 games. Multiplying that out is going to mean he's spending $2.50 on games. Subtract that from the $10 that he still has remaining. We're down to $7.50. divide by 75 cents, and the number of rides here that he could go on then would be less than or equal to 10. Okay, part B, what's the maximum number of ride tickets that he can buy? So if you want to know the maximum number of ride tickets, that would probably mean we're not spending any money on games. So if we start with our same equation here, um, instead, or what we want to do is assume that there's going to be 0 games played. So anything times 0 is still 0. So now we're looking just 75 cents per ride. We got $10 to spend. Divide by 0.75, and it's telling us that we would get 13.3333 repeating. Well, you can't go on a third of a ride. I don't think they let you do it there. So the maximum number of rides then that Manny could go on would be 13 rides. All right, letter C here. What is the maximum number of game tickets? So once you pause the video, see if you can figure out this. All right, if you were doing it right, you should assume that he's going on 0 rides then, and using all the money for games with the $10 he has left. So now you're just 25 cents a game with $10 divide, and the number of games, maximum number of games, if you divide that, is 40. So 40 games would be the most. All right, try some of the problems on your practice sheet doing the similar thing.